Hi, welcome you all for next embedded MCU series. In this video, we are going to see about GPIO programming, like how GPU is working in the microcontroller. So the topic that we will be cover in this videos are GPIO registers, input output, what is pull up pull down, and what is debouncing and all. So first, let's get into the introduction of GPIO. GPIO, you all know about what is the full form, which is nothing but general purpose input output. So general purpose in the sense, general purpose is nothing but it is not dedicatedly defined for single function. We can configure according to our requirement. Okay, it is not specifically or dedicatedly designed for any specific function. According to our user use case, we can able to configure the GPIOs. Okay, so input and output is nothing but input is the one which is used to read the external signals, and output is the one which is drive the external signals. So what are the key points in the sense? GPU generally can be configured under 4 category. According to the STM, I have written this. GPU can be configured as input device, or we can configure it as output device, or we can configure it as alternative function, which is nothing but I want to configure that particular GPU as I2C clock or I2C data or spy clock or chip select. So according to that, I can select by opting this alternate function option. Then we have the analog mode also. So these are the configurables available in GPIO. So we got some idea about what is GPIO. It is configurable. We can able to configure according to our use case. Okay, that's it. Then how the GPIO on single pin, how it acts as input as well as output. So what is exactly present inside the particular pin means inside that we are having 2 buffers and 1 enable lines. Okay, one is the output buffer and another one is the input buffer, and these 2 buffers will be controlled using a logic called enable pin. Okay, so the enable pin is the one which will select the particular pin. This is the pin which is visible to us via only we are connecting our probe or wires. Okay, so inside that we are having this configuration. It has the output buffer as well as the input buffer. Which one is going to act, like the particular pin is act as output or input, that will be concluded using this enable pin. Okay, I hope now it is clear. Then this is the logic behind the enable pin. So enable pin is that if my enable pin is set as 1, at the time the pin will act as input, and if my enable input is 0, at the time it will act as output pin. So input pin means enable is high, then this pin will act as a input pin. If my enable value is 0, at the time my pin will act as output pin. Okay, because this is active in this case, and in this case my output buffer is active. So how the particular pin is configured as input and output? It internally will have the output buffer and input buffer, and the selection will be made by using the enable line. Hope it is clear right now. Okay, now in this next video we are going to see what is exactly present inside the buffer. Now we have seen what is present inside the particular pin. It consists of 2 buffers. In the next video we are going to see what is exactly present inside the buffers. Okay, so this is the configuration or the components which are present inside the buffer. So this is the output buffer. Okay, so inside the output buffer we are having CMOS technologies, like it has the PMOS as well as the NMOS. Output in the sense, from the MCU it is going to reach the external device. Input in the sense, from the external device, like it may be a sensor or some other any external or any input devices, from that it is getting the input and it will reach my MCU. Okay, here it reaches my MCU. Here it reaches my, like we can have, it reaches the LCD. We can have LED. It is going to control my LED. So this is the thing present inside the output buffer. This is how PMOS, NMOS present inside my input buffer. Okay, now you got an idea what is present inside the buffer. Now we are going to see how the CMOS and NMOS are working according to the input. As we can see, input buffer, how it detects, here how the value is detected as 0 or 1, because it is the one which is connected with my MCU, isn't it? So for an example, I am getting value 1 from my sensor. Okay, this is the input, this is the value get from my sensor. The value is 1 here. Okay, so here the value is 1. When once it reaches the NOT gate, the value will become 0. And you must know PMOS will usually works when the value is 0, and NMOS will works when the input value is 1. Okay, now the value is 0. My PMOS will be active. What happened? VCC will be connected to this particular pin. This is how the current flow will. So the value, here the value is 1. This is one case. And another case is I am going with 0 input. Here I am getting 0 input. What happens? Here it is inverted as 1. And here I have mentioned if my input is 1, at the time my NMOS is active. Here NMOS is active and the PMOS is deactive. So what happened? This ground will be connected to the MCU. At the time the value is 0. Is it clear? So one case, if I am getting input 1, it will be inverted as 0, and if the value is 0, PMOS will be active. So VCC to particular pin is current flow. VCC to this we can say it as drain. Okay, from VCC to drain current flow will be there. So the input to my MCU will be 1. In this case, I am giving input, it is inverted as 1. If the input is 1, at the time PMOS will be deactive, NMOS will be high. So ground is connected to the particular pin and 0 value will be reached my MCU. This is how according to the input PMOS and NMOS act, and it will deliver the corresponding input to my MCU. Okay, I hope it is clear. Next, we are going to see two more concepts inside the input buffer. Currently, we are seeing input buffer. I am not getting into the output buffer right now. So, input buffer will have the two type of configuration. One is floating point and another one is pull up and pull down registers. So, floating point is nothing but, for an example, I am taking this example itself. This particular pin is floating. I am not connecting anything here. So the particular pin is open. I am not going to connect any external device or any peripherals to that particular pin, means this is open. So at that time the voltage at that particular pin will fluctuate between 0.8 volt or 1.2 volt or 1.7 volt. There is no constant volt in the particular pin. So we can say this is PMOS and this is my NMOS, and it is connected to this is my pin. Okay, this pin is open, so it will be fluctuating. So what happens, if it is 0, then PMOS is active. If it is 1, then NMOS will be active. Now for a change, let me take the color. If it is 0, PMOS will be active. If it is 1, NMOS will be active. But here the values ranges from 0.8 to 1.7. So it got confused and it started to conduct. In some cases PMOS will be active, in some cases NMOS will be active. It started to conduct like this. From this VCC and ground, there will be some current flow that's called as shoot through current, or we can say it as leakage current. Okay. So what is the solution? Instead of keeping this particular pin as floating, we have to use either pull up or pull down concept. Okay, the same thing I have explained here. So pull up or pull down. This is my just an inverted one. This is my input pin. Here I am having, this is my PMOS and this is my NMOS. This particular place is kept empty. So how this is how the current leakage will happen. So in order to avoid that, we are going with the pull up resistor or pull down resistor. We can say this is the low pull up or low pull down. So low pull up, low pull down is not pull up and pull down in the sense. When there is no external devices connected to the particular GPIO, it defaultly give the value as high. Okay, it defaultly give the value as high. In this case, if the particular pin is not connected, it defaultly give the value as 0. So what happens if it is 1? It will have the invert resistor and the change as 0 and my PMOS will be 1, and the default during default time it defaultly give 1 as value. Here it defaultly give 0 as the value. So why we are going for this pull up and pull down? To avoid the leakage current, because if I lift the particular pin as open, it will be go to the undefined state, okay, and it leads to leakage current also. So according to the use case, we can either choose weak pull up or weak pull down. If suppose I am giving 0, the value means since it is a weak pull up, automatically 0 will be given back to the MCU. Okay, so we have the two possibilities in order to avoid floating states. This is for input buffer. Next we can go with output buffer. So output buffer, the image is similar from the MCU. Here we are sending output from the MCU to my LED. Okay, so I am giving to my LED. In this case, here the input is 1. What happened? It is inverted as 0. If the value is 0, before we have seen, right? If the value is 0, then my PMOS will be active. If the value is 1, then my NMOS will be active. Okay. So 0, my PMOS is active. The value VCC2 current flow will be like this. Then the 1 will be given to my LED. We can go with the second states. Here I am giving input 0 from my MCU. Here where the input is getting, the input is given from my MCU. I mean from the program I am configuring this 0. It reaches here, it's changed as 1. If the value is 1, my NMOS will be active. And how will be the flow? It will be like from NMOS to pin. So the value is 0. Okay, this is how my MCU 1 and 0 values are drive inside the output buffer and it reaches the external devices. Okay. Next, in input buffer we are having two state. We are having floating state. In order to avoid that, we have chosen either pull up register or pull down register. It is a weak pull up and weak pull down. In output buffer we are having push pull configuration. Push pull configuration is nothing but when output is 1, PMOS is this is the same explanation. The another one is open drain concept. This is the push pull one, which is similar like the one which I have explained. In this normal case comes under the push pull. And this is the open drain with pull up. Open drain in the sense it is not having, this output buffer is not having PMOS. You can see here NMOS is only available. It is not having PMOS. So this particular state is called as open drain state. So you can see my inverter is directly connected to the NMOS and the particular pin. So in this case, it usually will be in 0th state. In order to avoid that, we are going with pull-up concept. This is open drain pull-up. So what is push-pull configuration open drain means? If I am going for multi-bus communication, it is not required. But for an example, I am going for I2C communication and all, then I am intended to select open drain configuration. Okay. In this, here both source and sink currents are active, whereas if I have the if I pull the line low, then only my external register is required to make it as high. Okay, this is some general differentiation. We can go through this. Let me say this open drain concept is mainly used in I2C communication only. Okay, in remaining cases we will go with push-pull configuration. So this is the general diagram of pull-up resistor and pull-down resistor. Already in input buffer itself I have explained why we are going for pull-up resistor in order to avoid pull-up or pull-down resistor in order to avoid the floating point states. So pull-up resistor is nothing but this is my output circuit. In the output circuit, I am using pull-up resistor. So what happens? It will be in high state. It will be in low state. So this push-pull configuration, this is the diagram of push-pull configuration. This is the diagram of open drain configuration. So that's all about GPIO programming. Now you have got some idea about what is present inside the GPIO and what is input buffer, output buffer, how the buffers are controlled using enable line, as well as inside the buffer, what are the CMOS technologies are working. Okay, that's all about GPIO. In the next video, we can have a program in STM32 and how it is fed into the STM32 nuclear board. That's all about today class. Thank you.